William, hello. I'm very happy to talk to you today. You will join the summit in the summer. Then we will have probably our first personal meeting. You are one of the few pioneers I think I never met in former times. But I know your name, of course, because Herbert loved your work very, very much, and he talked quite a lot about you and your work and how fantastic it is. So I want to know at the beginning how it started. Can you give some idea how you got in touch with computer art and computer animation in your case?
Okay, so I originally got involved with computing when I was a student at the Royal College of Art in London, and I was doing a lot of systems-based drawing, creating these large scale evolutionary drawings called form synths, which showed forms mutating, and I would draw them on paper, and I'd use a flow diagram to operate these rules, and I would use my brain as a sort of computer device to imagine what the transformations would be as a result of these operators being actioned. And I produced these vast drawings, somewhere about 30 feet long, showing these giant evolutionary trees. And I'd spent a lot of time in the Natural History Museum in London looking at the evolution of form in nature. And then off the back of that, John Lansdowne and Keith Critchlow encouraged me to get involved with computing. They saying, the computer will take this to the next level. I then was very, very lucky. I met some people from IBM. I showed them these large evolutionary drawings, and they said, well, that's really interesting. That's in line with some of our research. Why don't you come and join the IBM Scientific Research Center in Winchester in the south of England as a research fellow? So I was going to spend the next 6 years there. And then, so what happened was I went from art school, where I'd been doing printmaking, painting, sculptures. I'd made sort of quite minimalist style sculptures. I went straight into an advanced graphics laboratory. I'd learned how to program, but then I was paired with two really brilliant IBM programmers, Stephen Todd, who I'm still working with now, and Peter Quarrenden. And then I had access to all their software libraries, their big IBM mainframes.
You are one of the few persons I know that migrated really from art to programming. May I say that?
Yeah, I migrated. Yes, no, my father was an industrial chemist, so I'd sort of always been interested in molecular content. Yeah, so I migrated. I think I definitely trained as an artist and then migrated across, but I'd been very influenced by Russian constructivism, systems art, and then computing seemed a natural next step.
We are
For
talking
me.
about the 80s, right?
We're talking about 1985 when I was doing my form synth drawings, and then I went to IBM in 1987, quite a long time ago.
And what was the main purpose of this research lab and the team you were in doing? So what was the goal? I think it was not the goal to make art, but something different.
So the IBM Scientific Center was an IBM think tank. So they were working with archaeologists, molecular scientists, surgeons. They did the first modeling of the human heart. So it was set up by IBM to be an innovation center, and that what they wanted was to see interesting intellectual property emerge from that work. But what they were very interested in these collaborations with experts from other domains. So what they were interested with my approach was soft computer interfaces. So an interface where you don't have to have hundreds and hundreds of sliders, hundreds of numbers. The person just says, I like that. And then based on that input, the computer should be able to then do the next step. So they were interested in soft interfaces, intuitive interfaces.
Yeah, but they were also interested in making content, I think, or making programs to produce content, say it this way, for the scientific community, or did they think about commercial activities as well?
So IBM at that time was quite experimental with these scientific centers. They believed that if you just brought bright people together from different domains, interesting software applications would develop from there. So it was many ways like a kind of Renaissance situation, because you had programmers, mathematicians, experts. So it was a wonderful place because I was given freedom to make computer art, and we developed unique software to make that art. And then in the background, there was all this other, wonderful activity going on. And in fact, the original structure, so the image behind me is from that period, was based on a protein structure that had been used for molecular graphics. And that was the first thing that we started to mutate and make art. So that the basic grammar came from protein folding right from the very start. And that influence of structural biology has continued right the way through the work.
Were biologists or chemists interested in that kind of software to use it for their scientific research, or was it not so interesting for the scientific world at that time? Because I have the feeling in science world, and Herbert also told that to me, the visualization of content was not so much important for most scientists. They tried to stick to the formula and thought that is more important. What is your opinion about that, or your what did you see in the history when you worked with such kind of content and programs that could also be used for scientific research?
So at the IBM Scientific Center around 1990, they were doing scientific visualization and simulation. And they were interested in my work with the rendering quality, we'd push the quality, the lighting, we'd refine. We were using a unique ray tracer called Winsome. So we were pushing, for the art, we were pushing the visual quality all the time. And so the scientists used those rendering qualities within their work. But I think at that time, IBM was getting into scientific visualization and molecular work. But in some ways, within the scientific center, it was like a triangle. You had the scientists, you had the engineers on the software side, and then I was the art on the other corner. And so the scientists are always keen on their true data being presented accurately. But I guess within IBM, we had this kind of, I call it the golden triangle: art, engineering, and science. That there were people from all those corners working together.
Mm-hmm. And can you tell us a bit about the biggest challenges you had at that time doing your work and producing such beautiful images? Let us share a bit this time. It was definitely different to nowadays.
So yeah, the challenges were enormous because there was no Photoshop, Windows wasn't around. So we were using big IBM mainframes to record just a single image, like the image behind would take 2 hours. And then recording to video was really, really complicated. You had to sort of, recording to film was even harder. We were working in a kind of Unix type environment. the big plus was that I was having software created for me, which was, luxury. Um, Big hostility from the art world, completely different to now. The art world has hated computer art, and there was interesting work with Mandelbrot's fractal. The fractal geometry was starting to gain popularity, but really, if you were making computer art, you really had to leave the art world, and you were in a new domain. And I was happy in this domain. And then, IBM funded my exhibitions. I fly around the world, do really what I like, funded by IBM. So for me personally, it was like a great sense of liberation. I could just do interesting stuff and see what happened. We did write papers, and IBM were interested in the IP being applied in other domains. So, for example, in business planning or visualization.
So I think I almost do not have to ask the question because the answer is very clear by what you said so far. Asking what is more important, the code or the image?
A very good question. Because we've developed a lot of software we call it the mutator. And we've now added on physics libraries. This is all custom written. We've got an AI module, we got a VR module, we got it working with Azure, and this is kind of thousands of lines of code. And in some ways that is the artwork, because implicitly, this system could produce art indefinitely. It does require me as a human user or another human user to be the breeder, if you like. You're the aesthetic selector. And so, we're talking to museums, they've asked me this question, like, can we, buy the software, because everyone's thinking is all captured in the software. The challenge is maintaining that software, particularly, Stephen and I are thinking about this, how we strip the code down, because, if you have a new graphics card come out, there's continual maintenance on software. And, technology is moving so quickly. How do you guarantee that software is easy to maintain? So I think you could say my artworks, like, are really just instances or expressions of the software. They are just examples, if you like. But what is interesting about the software having created is I can create things that are beyond my imagination. That's why it's quite addictive working with this type of software. But it's a good question. I think ultimately it needs to be put into a software escrow and long-term archive. It's probably too big for the blockchain.
Can you give us some idea in comparison, definitely, to, for instance, Herbert's first Apple programs, which were 20, 30 lines? Can you give us an impression how big the code was you made your first videos?
You do thousands of lines of code, and we were pulling in other libraries like the Winsome renderer. That was a software library in its own right. We've recently resurrected that. So we're looking at thousands of lines of code. And I think one of the other challenges we have is that Stephen and I work very creatively. And so the code is a little bit untidy, very untidy, because what will happen is I'll have an idea and say, can we add physics to do this? And Stephen will add it quickly. And then, because I want it quickly, but the engineering is quite untidy under the hood. And so again, for long-term maintenance, we'll have to clean the code up.
You speak about this time that was very fantastic for you, but nevertheless, you left the team and you moved back into university life. And Well, I'm interested to hear what was behind that decision. Why did you move back from industry to where you did a nice job, where you had wonderful environment? Why did you go back to university?
Okay, so a good question. So in 1993, there was a recession, and IBM closed their scientific laboratories. But what had happened was that I'd built up a big following in rave music, and then I was approached by lots of bands to create their graphics. So I left IBM and set up a small studio in Soho, in the middle of London. It was like an attic. So I went from corporate IBM to Soho and I created a small team, and we started to work with rave music. So, in the same way, there's lots of hype around hallucinogenic stuff now. Back then, it was all rave and cyberdelia. It's like, and I was seen as part of that. In fact, whilst at IBM, my work had built up this huge following, like was being shown at raves and big warehouse parties and things like that. So there was a big audience for my work. So then I spent 10 years in the games industry, and then ended up, I got approached by Universal Studio to create a game based on the film called The Thing, because of the organic look of my work. And then finally I escaped after 10 years, and then went to Goldsmiths, where I became a professor.
So we are coming to the 21st century and the new developments that are called crypto art and AI art. I'm very interested to hear what a pioneer doing wonderful work in the last century already. What do you think about these new developments, and especially as you are also at a university and teaching young people? How is your access to this, and what do you think is the importance in generative art, what's happening right now?
Okay, so yeah, very interesting. So a number of researchers have highlighted that Mutator is a particular branch of AI, in particular in the way it anticipates what the person wants. It is a form of AI, and in particular, we have this creative partner model. So there's the artist and the machine, and the control is flipped back and forth. So my approach has been not to hand over to the machine completely, but to have a creative partner. So I think the current AI work is very interesting, but what we're really seeing is clever use of statistics, increased compute power, and obviously the use of large language models. So we're not seeing true AI. In some way, so it's an interesting time. Certainly the results from Midjourney and things like this are quite extraordinary. But ultimately, you feel sometimes it's like a series of happy accidents. The artist kind of makes do. The results look very polished and slick, but are the results what they really want? There are lots of interesting people in this space doing, very clever work. To me, using photo training data is cheating a little bit, like just using photos. As I mentioned earlier, my interest in structural biology is I'm interested in structure for three-dimensional form, not just collaging of photos. So yeah, I think that culturally it's very, very radical. This is like what's happening is as big a shift as cubism. It is a radical step forward. To me, I'm just, I think we're seeing very interesting work, but I just not always sure that the quality is as good as it could be. And maybe some of the works look a little bit like image processing, have a particular look, the way images flip and change. but sorry, I'm being a little bit negative, but definitely it's got me and Stephen thinking more about AI, how we bump up the AI component within Mutator.
William, I think we are at the end of our talk now. I really appreciated your words and your informations, and I'm looking forward to meet you in Berlin. So,
okay.
Bye-bye.
Okay, thank you, Susanne. Thank you. Look forward to seeing you in Berlin.